Welcome to 2.3, more difficult decimal division. So these problems seem similar, but they have important differences. Evaluate all of them. Decimal straight up, 2 goes into 8 4 times. 2 times 4 is 8, remainder 0. Bring down the 6, 2 into 6, 3 times. Remainder 0, so this is 0.43 or 43 hundredths. 20 goes into 8 0 times, decimal straight up. 20 into 86 goes 4 times, the 4 has to go above the 6. 20 times 4 is 80, remainder 6. We're out of numbers, so we bring down a 0. 20 into 60, 3 times. 20 times 3 is 60. Whoa, that's this, right? You don't need that 0, although some teachers are insistent you do. And that's the same answer, 43 hundredths. One more time. 200 doesn't fit into 8, so we put 0 there. 200 doesn't fit into 86, put 0 there. Now 86 has a decimal point, so we got to put it and put it straight up. Now we add a 0. 200 into 860. Well, I think that goes 4 times, because 200 times 4 is 800. Remainder 60. 200 doesn't go into 60. We need to bring down a 0. 200 into 600. 3 times. 200 times 3 is 600. And all of these had the same answer, 0.43 or 43 hundredths. So all of those had the same answer. And it's very much, right, they all equaled 43 hundredths. Those are the problems from the warm-up, right? We know that 1/9 and 2/18 and 3/27, right, all simplify to 1/9. They are equivalent. Well, similarly, those are equivalent because they all simplify to that same 43 hundredths, and we'll see that today. Right. So we have no way to divide by a decimal. We can divide decimals, but we can't divide by them. And what do we mean by that? Well, this is 1.28 divided by 0.4. Just like you can't have a 0 out there, you can't have a decimal out there. So what do you do about it? Those who know, go ahead and do it. Well, we can't have a decimal out there, so we're going to move it. And we're going to make that decimal point over there. And we've changed 4/10 into the number 4. But we can't just do that, or the problem won't have the same answer. We need a problem that will have the same answer as our original problem. So to do that, we also have to move the decimal point there. And so the problem we're going to do is 12.8 divided by 4. Now on a calculator, you could do 1.28 divided by 0.4. But without a calculator, you're going to need to move the decimal point the same amount of times inside and out. So whatever you move it on the outside, you have to move the decimal point the same amount on the inside. So let's see that. 4 doesn't go into 1, but it goes into 12 3 times. The 3 goes above the 2. Decimal point is there, so it goes straight up. 8 goes straight down. 4 into 8, 2. And so the answer to the original problem and the one we did is 3.2. So try this one. So right, the first number goes inside. So this is 5 divided by 0.8. Well, you can't divide by 0.8. It's not allowed. It won't work. So we have to move it there. Now, where is the decimal point in 5? It's right there. So we still have to move it. So we moved it over there. Well, I just created an empty space. What do you always fill empty spaces with in math? Zeros. So the problem we're going to do is 50 divided by 8. It has the same exact answer as 5 divided by 0.8. 8 doesn't go into 5, but it goes into 50, right? 6 times. 6 times 8 is 48. Borrowing, remainder 2. Out of numbers. Before I put that 0, we're going decimal straight up, right? 50 has a decimal point, and we moved it right there. Bring down the 0, 8 into 20, 2 times. 2 times 8 is 16. Remainder 4. Need another 0, 8 into 40. 5 times, 8 times 5 is 40. And the answer to our original problem and the one we did is 6.25, or 6 25 Right? So product means multiply. What does quotient mean? It means divide. We're dividing today. So whenever you're told to find a quotient, you're dividing. So this has one negative in the answer. So what's the answer going to be? It's going to be negative, and you might want to put that before you go do all the work. So we're going to do 8.4 divided by 0.12. Now we're going to have to move the decimal twice. 1, 2. Can't divide by 0.12 or 1.2. We have to divide by 12. So we moved it twice that time. That means we have to move it twice over there. We have an empty space again, so the problem we're going to do is 840 divided by 12. 12 doesn't go into 8, but it goes into 84 exactly 7 times. 12 times 7 is 84, remainder 0. Bring down a 0. 12 into 0. You have to put that 0. Let's say it goes in, 12 goes into 84 7 times, but it goes into 840 70 times. And so the answer to this was negative 70. So a lot of little details there. Try this one. Well, it has two negatives, so the answer is going to be positive. This is 4, or it's negative 4, divided by negative 0.05. So once again, we have to move the decimal so that it no longer has a decimal point in it. In other words, it becomes a whole number, right? We made the last one a whole number 12. Now we're making it the whole number 5, because there is no number 0, 5. Now we moved it twice there, so that means 4's decimal point, which starts there, has to also be moved twice. So that becomes 400. So the problem that has the same answer as this one is 400 divided by 5. 5 doesn't go into 4, but it goes into 48 times. And just like the last one, we have to say 5 goes into 0 0 times. So the answer to this one, because it has two negatives in it, is positive 80. Yeah, 5/100ths, 0.05 goes into 4 80 times. Okay, now you learned last year, hopefully, that there is a thing called a repeating decimal. What makes repeating decimals is when you divide by the 3 times table, like 3, 6, 9, 12, and I could keep going, 15, 18. When you divide by those, it either goes in nicely, as in 12 divided by 3 is 4, or it is a repeating decimal. Now, other numbers also make repeating decimals. A lot of prime numbers, not all of them, but a lot of prime numbers like 7, 11, you divide by 13, 17, yes. Also, when you divide by prime numbers or the 3 times table, you will either get a nice answer or a repeating decimal. You never get a regular decimal, never. It's either whole number or repeating. So let's see that. So 1.6 divided by 3. Now, this is already a whole number out here. We're doing repeating decimals. We're not moving the decimal point. So we don't have to fix it. So let's just do the problem. So 3 doesn't go into 1. It goes in 0 times, decimal straight up. 3 into 16, though, right, goes 5 times. 3 times 5 is 15. Remainder 1. Bring down a 0. 3 into 10 goes 3 times. 3 times 3 is 9. Remainder 1. Bring down a 0. 3 into 10. 3 times. 3 times 3 is 9. Remainder 1. Bring down a 0. 3 into 10. And you hopefully can see that this 3 is going to go on forever. Now, we don't have to write 3 forever. We're going to put little dots on the end here, but we're going to write it 2 ways, right? It can be 0.53, right? There's the decimal point. You can put the leading 0 there if you want. And then you can put these 3 dots. But most of the time, that's not what we're going to do. We're going to put decimal 0.53. Now, which part was repeating? Was the 5 repeating? No, just the 3. So you put what? A bar above the 3. And a lot of teachers are not clear on how to say this. So let's make sure I want you to write this down. You say this as 0.5 with 3 repeating. Okay, that indicates the 5 doesn't repeat, but the 3 does. And that 3 repeats forever. There's no such thing as a little bit of repeating in a repeating decimal. It repeats forever, whatever part that repeats. So let's try another one. You know the answer is going to be a repeating decimal. You should also know the answer is going to be negative, right? Because we have one negative in the problem. So we're going to do 2.6 divided by 6. So 6 doesn't go into 2. Decimal straight up. 6 into 26. 6 times 4 is 24. Remainder 2. Bring down a 0. 6 into 20. 3 times. 3 times 6 is 18. Remainder 2. Bring down a 0. 6 into 20 goes 3 times. 3 times 6 is 18. Remainder 2. Bring down a 0. And once again, we got another 3. It's not always 3s. And this one is negative 0.4 with 3 repeating. The 4 doesn't repeat, but the 3 does. And there are more complicated repeating patterns. But when you divide by the 3 times table, 3, 6, 9, 12, 15, and so on, you're going to either get a nice answer or a repeating decimal. So let's see what happens here. So this combines everything we've done. 0.2 divided by 0.09. So pause the video and do it yourself. So we move the decimal twice and make that 9. That means we're moving the decimal twice there, adding a 0 and making that 120. 9 doesn't go into 1, but it goes into 12 once. Remainder 3. Bring down a 0. 9 into 30. 3 times 9 is 27. Remainder 3. Now 120, decimal point is right there now. Decimal straight up, 0 straight down. 9 to 30, 3 times. Oh, I should have picked ones with other repeating decimals other than 3. Right? And bring down another 0. 9 to 30 goes 27. And we get 3s forever again. Now, when we write this, right, it's going to be 13.3 repeating. That's how you would say that. Notice the bar, this repeating bar will never go over onto the left side of the decimal point. There's no such thing as a repeating whole number over there. And so this is not 30, it's 13. And right, 13 and 3 repeating. It is not 3/10. All right, and you're all right. 13 and 3 repeating. Okay, now, I guess I should write out the word 3. All right, yeah, it's not with because it's and. Where the decimal point is, you say and. Now, it is not equal to this. So that's why you can't say that. You're going to learn this year that it's actually equal to 13 and 3/9. So it simplifies to 13 and 1/3. So you don't say 3/10 for repeating decimals, or you don't say tenths, hundredths, or thousandths for repeating decimals. They actually, you're going to learn they're ninths, 99th, and 999th most of the time, not always. So we're going to use our powers of rounding now. But before that, this is 0.179 divided by 0.06. So fix that problem. So it's move it twice, that becomes 6. Move this twice, that becomes 17.9. So instead of doing that, what I'd like you to do is realize that 17.9 is around 18, and 18 divided by 6 is 3. So this, right, if you know your rounding, right, and it's a multiple choice test, you know that answer has to be around 3. 6/100ths fits into that thing around 3 times. Same thing here, you're going to have to fix it first, then round. So look at that horrible number. Right, do you really want to do all that work, or you want to use your powers of rounding? Move this twice, make it 6. Move this twice, it's now 11.959. Well, that's around 12, right? 12 divided by 6, 2. Okay, this is very important skill, right? Math teachers, it drives us crazy when you write answers that make no sense, right? This is around, right? Everyone can do 12 divided by 6. So all you have to know is that this answer is around that, and you get the answer right. So we're at the practice. Do them without my help. One negative in the problem, so negative 12.2 or negative 12 and 2/10. Whoops, no, first number goes inside. Right, 0.0, right, now we have this, right? We don't need a 0 there, so that's plain old 5. So the problem that's the same, 5 divided by 9 has the same answer as that, because two negatives make a positive. So 9 doesn't go into 5, decimal straight up, add a 0. 9 into 50, well, 5 times 9 is 45, remainder 5. Bring down a 0. 9 into 50, 5 times. 5 times 9, 45. Remainder 5, bring down a 0. 9 into 50. Finally, we have an answer that's not 3's repeating. All right, so this is 0.5 repeating, which again is not 5/10. In fact, it's 5 divided by 9 or 5/9. As I said, repeating decimals are not tenths. Don't say them that way. Rounding. Well, that's pretty much the same as 72 divided by 8, which is 9. Thank you very much.